Dear students, in this particular session, I will be discussing the concrete mix design procedure using the updated version of IS 10262, which is IS 10262 2019, and by using IS 456. So here we will try to understand the procedure of doing this mix design through this particular illustration. So the stipulations for proportioning are as under. Grade designation which is given M25 grade we are designing. The structure is RCC, made up of RCC. Type of cement is 43 grade OPC, ordinary Portland cement. Maximum nominal size of the coarse aggregate is 20 mm. Minimum amount of cement is 300 kg per meter cube as per IS 456. Maximum water cement ratio permissible is 0.5 as per table 5 of IS 456 2000. Workability is given as 75 to 125 mm slump. For that slump, we are designing this mix. Exposure condition is moderate for reinforced concrete. Method of concrete placing is pumping, and degree of supervision is good. Type of aggregate is crushed angular aggregates, and chemical admixture used is super plasticizer. So these are the test data for the materials. Cement used is the brand Sagar 43. For this illustration, we are considering this particular type of cement as an example. Specific gravity of cement is 3.14. Chemical admixture is a super plasticizer. Specific gravity of coarse aggregate of 20 mm size is 2.799, and coarse aggregate of 10 mm size is 2.789. Combined specific gravity of coarse aggregate, so which means 20 mm 60% we are taking in the during the casting, 10 mm 40%. So this is nothing but called as blending. So blending is done here. So 20 mm we are using 60%, 10 mm we are using 40% in order to get the dense gradation. Then the specific gravity of such a combined mix is 2.795. Fine aggregate is 2.517. Water absorption for coarse aggregate is 0.41% for 20 mm size, and coarse aggregate for 10 mm size, the water absorption of 0.59% is considered. Fine aggregate water absorption is 1.87%. Aggregate impact value is 20.52%. Combined flakiness and elongation index are 27.57%. And as per the sieve analysis, so these values which are shown in the bottom, it is given. So coarse aggregate conforming to all in aggregate of table 2 of IS 383, fine aggregate conforming to grading zone 3 of table 4 of IS 383. So now we will begin the steps one by one. So let us start from the target strength calculation for mixed proportioning. So we have got this particular equation, that is nothing but FCK dash is equal to FCK plus 1.65 S. So the same equation which was prescribed in the IS 10262 2009, here it is mentioned. So where S is nothing but standard deviation, as you are aware of that. Another equation as per the new code is this one, FCK dash is equal to FCK plus X. So this X is nothing but the value to be taken, to be chosen from table 1 of IS 456 2019. the updated version of IS code. So here in the above equation, as you know, the FCK dash value is nothing but the average target compressive strength of concrete at 28 days. FCK is equal to characteristic compressive strength of concrete at 28 days. X is the factor based on the grade of concrete, which is to be read from this particular table 1. Standard deviation from table 2 of IS 10262 2019. So that means this table we have to refer, the second one. So now we will check what are the values of S and X as per the given condition. So we will compare it with the standard conditions which are given in table 1 and table 2 respectively, and we will try to work out the values of X and S. Okay. So this the table 1, which is nothing but the first column, it is about the grade of the concrete, and the second column, it is about the value of X to be taken. Now in our case, so we are designing the grade, which is nothing but M25. M25 is the grade we are taking here. So for M25 grade, we have to take the value of X as 0.5. So the value of X is taken as 5.5, sorry, 5.5. So this value FCK dash is equal to FCK plus X, this formula, we are substituting this value. So characteristic compressive strength is nothing but 25. 25 M25 grade we are designing. So plus 5.5 gives you the value 30.5 Newton per mm square. Okay. Whereas from the first criteria, FCK dash is equal to FCK plus 1.65 S. So FCK is same 25 plus 1.65 into S value. We have to take S value is nothing but from table 2 we have to read, and from table 2. So for M25 grade, so 4 is the value. Okay, so the same it is taken here 4, and the value works out to be 31.60 Newton per mm square. So here always you remember one thing. Now you are having two values. So one is 31.6 and another one is 30.5 Newton per mm square from these two criteria. So we have to adopt whichever is higher one among this. Why? Because the target compressive strength should be higher. Okay. So among this 31.6 Newton per mm square is higher. So the same one I'm taking here 31.6 Newton per mm square. Okay. It is nothing but the target compressive strength. Next is nothing but the approximate air content. Approximate air content. So this is the new step which has been introduced recently in the updated version of IS 10262 in the code IS 10262 2019. From table 3, we have to refer there in the updated code IS 10262 2019. So from this, we can see here that a particular value of entrapped air in terms of percentage which is given for particular nominal maximum size of aggregates. So here you can see 10 mm it is 1.5, 20 mm it is 1, 40 mm it is 0.8. So now here as we are taking 20 mm nominal maximum size, so we can select 1% is the approximate air content in the concrete. Okay. So this value holds good whenever we are preparing or whenever we are casting non-air entrained concrete. Non-air entrained concrete in the sense, so entrapped air is different, entrained air is different. Entrapped air is nothing but, so we are not introducing the air into the concrete intentionally. Intentionally. So non-air entrained, it is nothing but that condition. Okay. So air entrained in the sense, it is nothing but we are intentionally introducing some air content by making use of air entrainers as admixtures. So that condition is different. So this holds good for non-air entrained concrete. Okay. Next is nothing but selection of water cement ratio. So selection of water cement ratio here, we are having two criteria again. Okay. So first is based on the type of cement, we can able to select a particular water cement ratio now. So IS 10262 2019, which allows you to select a particular water cement ratio based on the grade of cement. Okay. So here, when you see this particular chart, that is nothing but given in figure 1 of IS 10262 2019. Okay. So there you can see the variation of 28 days compressive strength of concrete in Newton per mm square with respect to free water cement ratio, free water cement ratios. Okay. And that too, you can see these variations not for only one type of cement. So there are three types of cement. So therefore, three distinct curves you can see here in this particular uh, chart, okay, or the graph. So there, the upper one, the upper curve, which shows for 53 grade of OPC, and the middle one, which shows or which holds good for 43 grade of OPC, and the bottom one, the lowest one. So among these curves, so which will be hold good for or which holds good for 33 grade of OPC. Okay. So now in our case, as you have seen in the beginning, the data. So we are using OPC 43 grade. Okay, OPC 43 grade means so this particular curve has to be referred. This particular curve has to be referred now, the middle one. Okay. Now to refer this particular curve, we need some inputs. Okay, what are the inputs? Inputs are nothing but what? So as I said, it is the cement. Obviously, the type of the cement is one of the input, and another input is nothing but the target compressive strength. So target compressive strength in our case is 31.6. Okay, 31.6 lies here. 31.6 somewhere here. Okay, when you produce a straight line from this vertical axis, okay, from this vertical axis, you are going to get a horizontal line. Okay, like this. So until it cuts the middle curve. Why? Because middle curve. So it is for OPC 43 grade we are referring. Okay. So now straight away we can extend this point vertically downward. Okay, vertically downward. So wherever it touches the horizontal axis, that value should be referred as pre-water cement ratio. Okay. So now if you carefully do this procedure or carefully follow this procedure, and you will come to know that somewhere 0.48 will be the water cement ratio. 0.48 will be the water cement ratio. This is one criteria uh, of choosing water cement ratio using IS 10262 2019. The second criteria is nothing but what based on the durability aspect. Okay, based on the durability aspect. So based on the durability aspect, we have got the IS 456. The usual in the usual procedure also we have used this particular table IS 456. So this is an abstract from IS 456. Okay, so there this particular table 5 should be referred in order to select a particular water cement ratio depending upon the durability. Okay, so here minimum grade of concrete is given, minimum cement content is given in the first column. Second column, maximum free water cement ratio is given. Minimum grade of concrete is also given. Okay, so in our case, so we are referring to this particular condition. That is nothing but what severe condition. Okay, severe condition. So there in the severe condition, you can get the minimum cement content, maximum pre-water cement ratio, minimum grade of concrete for plain concrete. Now we are referring this one, reinforced concrete. In this particular problem or illustration, we are referring this particular condition, referring the reinforced concrete. So for the reinforced concrete, we have got somewhere 320 kg per kg per meter cube is the minimum cement content. 0.45 is nothing but maximum pre-water cement ratio, and minimum grade of concrete is nothing but what M30 to be provided minimum grade. Okay, so now this particular whatever the problem or the illustration, so we are referring the severe condition. So severe condition we need to have, or we need to observe the water cement ratio. So water cement ratio is given, or which can be taken as this one. What is that? 0.45. Okay, 0.45 is nothing but what? Our water cement ratio from the durability aspect. So always you go for the lesser water cement ratio. Okay, considering the durability aspect. Okay, so lesser water cement ratio means, so water by cement ratio, if it is lesser, means then we'll be getting the maximum benefits. Okay, so in the uh, from that particular concrete, regarding the durability. So in the durability chapter also I had explained. So particularly in the creep shrinkage there, as well as in the upcoming topics also I'll be discussing what are the significant effect of choosing a particular or lower water cement ratios. Okay, always. So here in the from the second criteria, from the durability aspect, we got 0.45 water cement ratio. Now we have two values, 0.48, 0.45. Adopt the always lesser one, 0.45. Now again, for this illustration problem, I will be selecting a water cement ratio which is further, or which is still lesser than that, 0.44. Let us say take 0.44 as the water cement ratio. Okay, so now the next one is nothing but what? The selection of water content. Okay, selection of water content. So from table 4 of IS 10262 of 2019. So this is the table 4 of this particular code. So which is nothing but what? The water content values which are given for a particular size of aggregate, nominal maximum size of aggregate. So in our case, we are using a 20 mm nominal maximum size. So definitely we have to select 186 liters. Okay, 186 liters of water. Okay, so that too, this values holds good for 25 to 50 mm slump range. Okay, these values, all these values holds good for when the slump value is in the range of 25 to 50 mm. Now, furthermore, if the slump is increasing, so it is nothing but beyond 50 mm, so then corresponding correction has to be adopted to this water content. So what is the correction? As you know, for every 25 mm increase in the slump, okay, we need to raise this water content by 3%. Okay, 3%. So here in this particular illustration, so we are referring to the condition where the slump of 125 mm is considered. Okay, so 125 mm means nothing but what? So 125 minus 50 is nothing but how much? It is 75. So 75 means nothing but what? So 2 into 25. Okay. Sorry, 3 into 25. That means nothing but what? So 25 into 3, 75. So that means, so for every 25 mm increase in the slum, we need to raise the water content by 3%. Okay, 3 into 3. So that is nothing but what? 9%. 9%. So the 9% we are adding here. So final water content will be nothing but what? 202 liters. Okay, 202 liters. So this one. So based on the trials, again, super plasticizers, since the super plasticizers are used in this particular condition, so based on the trial, it is given that so nearly 23.76% of water content can be reduced. Okay, can be reduced by the use of the super plasticizer. So if you reduce that, so from 202 liters, so how you can reduce? So net required water is equal to 202 minus 202 into 23.76%. So we are getting this final uh, figure. So that is nothing but what? 154 liters. So which is nothing but what? Net required water. Net required water. Okay. So this should be taken now. The next one is nothing but what? Calculation of cement content. Calculation of cement content. As discussed earlier, based on the trial water cement ratio 0.44. Cement content, which can be taken as water by cement ratio, we have got 0.44 now. Okay, 0.44 now. Okay, so water content we know. Water content we know just before in the previous slide we have calculated that. So somewhere about 154. Okay, so 154 liter was the water. Okay, so now I'm using the same water for calculating my cement content. Okay, so as you know, water by cement, so that is equal to what in our case is 0.44. Okay, so water is nothing but 154. So 154 divided by cement is equal to 0.44. Now we can calculate what is the value of cement. So cement is equal to 154 divided by 0.44. 154 divided by 0.44. The same thing it is done here. Okay. So 154 divided by 0.44, final figure is 350 kg per meter cube. Okay, 350 kg per meter cube. Now, this 350 kg per meter cube we have to check from the table 5 of IS 446 for the minimum cement content. Okay, for the minimum cement content. So here the different conditions are there. I think we are referring to this moderate exposure. Moderate exposure. So just I will verify this exposure condition. Exposure condition is moderate. Yes, yes, yes. So exposure condition we have taken is moderate. So that change has to be made here. So that is nothing but the water cement ratio also. Just see here, water cement ratio. So moderate we have to take. So moderate is nothing but what this value we have to select. So minimum cement content is 300 there. Maximum pre-water cement ratio 0.55, zero point 0.5 only. Okay, zero point 0.5 only. So and the minimum grade of cement is nothing but M25. Okay, so this is nothing but what the correction, a small correction has to be made there. Okay, so this is for moderate condition. Hmm. So there is no change in the water content, but the cement minimum cement content we have to check now. It is given as 300. Okay, 300. Earlier we had I think taken the condition of severe. So make that correction. Okay. So for this minimum cement content, now what is that minimum cement content we have got? So moderate 300, okay, for reinforced concrete section. So this 350, whatever we have provided kg per meter cube, which is greater than 300 kg per meter cube. Hence it is okay. Hence it is. Hence the provided cement content is okay, right? Next step is nothing but what we have to calculate the proportion of volume of coarse aggregate and fine aggregate content. So, in order to do this, so we have to refer the table number 5 of IS 10262 2019. Okay, so this is that particular table. This is that particular table where the nominal maximum size of aggregate is given as well as the volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate is given. Okay, zone 4, zone 3, zone 2, zone 1 for different zones. So this volume proportions are given. So now in our case we are referring to the condition where 20 aggregate size are used. Okay, 20 size is used. So 20 aggregate size. So as well as zone 3. Okay, so which is nothing but what 0.64. 0.64 is nothing but what the volume of the coarse aggregate. Okay, volume of the coarse aggregate. So this value holds good for what when the water cement ratio is 0.5. When the water cement ratio is 0.5. Here this zero point 0.5 is not in our design procedure. That means nothing but what in the previous steps we have considered the water cement ratio which is lower than this, okay, which is nothing but what 0.44. Now for this reduced water cement ratio we have to oh, do the correction. Okay, so we have to take the correction factor. So what is that? So as you know in the previous code of IS 10262 2009. So this whatever the correction wa was given. So it is nothing but as the water cement ratio is lower by uh, 0.005. okay, 0.05. Okay, so then we have to raise the the this proportion by 0.01 and vice versa. So that means nothing but you can see here the sign convention. So that is nothing but minus or plus, okay, plus or minus. So that means whenever the water cement ratio is increased, so this proportion has to be reduced. Whenever the water cement ratio is decreased, this proportion should be increased. So now this is the second is the condition. So now water cement ratio is decreased in our case. So corresponding increase in the proportion we have to make. Okay. So corresponding increase in the proportion we have to make. So let us see what is the correction required here in our particular case. Okay. So this is nothing but what for zero point 0.5. So this is the 0.64 is the value. Okay. For every 0.05, for every 0.05. Okay. So that means drop, drop we are considering. So this value proportion has to be increased by 0.01, 0.01. Okay. So now in our case is what? So 0.64 is the proportion we have got. Okay, 0.64 is the proportion we have got for water cement ratio 0.5. Okay, for water cement ratio 0.5. So what is the reduction? It is 0.5 minus 0.44. Okay, 0.44. What is the reduction here? 0.06 is the reduction. Okay, 0.06 is the reduction. So now 0.06 reduction. So what is that? How much should be raised? That proportion how much should be raised, so that we have to take. So 0.06 is nothing but the reduction. So cross multiply. So cross multiply this. So 0.06 divided by 0.05 into 0.01. Okay. So this is has been done here in this particular step. Okay, in this particular step. So finally, you will be having the value which is nothing but what? 0.012. Okay, 0.012. So this 0.012 has to be added to this 0.64. So now the final proportion, okay, final proportion of this coarse aggregate, okay, volume proportion of this coarse aggregate works out to be what? 0.64 plus 0.012, this is 0.65, 0.65, okay. However, this is not the final proportion, what I can say. So this proportion has to be uh, again corrected, okay, if it is a pumpable concrete, if it is pumpable concrete. Why? Because the reason is nothing but what? If the concrete is pumpable, we simply not intended to use more coarse aggregate, more coarse aggregate. Why? Because workability will be affected. So therefore, or it is nothing but what, the this particular fraction of the coarse aggregate has to be reduced now. Okay, reduced to suitable extent. Okay, so this particular code IS 10262 2019 specifies that for pumpable concrete, so we can reduce this proportion by 10%. Okay, we can reduce this volume of coarse aggregate fraction by 10%. So after the this particular reduction, so this is 0.65 into zero point 0.9, that reduction. So final figure is nothing but what? 0.59. Okay, 0.59, so we can make the round figure, it is nothing but 0.59. So now we can calculate what is the volume of the fine aggregate content. So fine aggregate content is nothing but 1 minus 0.59, which is nothing but 0.41. So 0.59 is nothing but what? Coarse aggregate fraction. 0.41 is nothing but fine aggregate fraction. Remember that. Okay. Now here the mix calculations in the this particular mix calculations, so which can be done as follows. Okay, so volume of the concrete which we are taking is nothing but 1 meter cube. Volume of the entrapped air in the wet concrete is 0.01 meter cube. Okay, that is 1%. Then volume of the cement is nothing but the standard formula is there, mass of the cement divided by its specific gravity into 1 by 1000. Okay, into 1 by 1000. So it is nothing but what? 0.111 meter cube. Volume of the water is nothing but mass of the water divided by its specific gravity into 1 by 1000. So using that, we'll get the volume of the water as 0.15 meter cube. So assume the uh, trial, that is nothing but what 0.5% by weight of the cement of super plasticizer or admixture which can be used here. Okay, so that is nothing but volume of the admixture is equal to mass of the admixture divided by specific gravity of that admixture into 1 by 1000. So here that value is should it is considered now. Okay, so that is nothing but 1.75 kg. So the admixture um, mass, it is nothing but 350 kg is nothing but cement's mass into 0.5% of that. So 1.75 kg. Okay, 1.75 kg divided by its specific gravity into 1 by 1000. So this is particular value 0.0016 meter cube. Then uh, volume of the all in aggregate is works out to be A minus B minus C plus D plus E. So you can refer this A, B, C, D, E. Okay, in the above steps. So the same thing we have to substitute here. So finally we will be getting the volume of all in aggregate as 0.723 meter cube. 0.723 meter cube. Okay. So the next is nothing but mass of the coarse aggregate. So mass of the coarse aggregate, the all in aggregate into volume of coarse aggregate into specific gravity of coarse aggregate into 1000 we have to do. So 0.723 into 0.59 into 2.795. Okay, the specific gravity into 1000. So this is nothing but mass of the coarse aggregate. Similarly, mass of the fine aggregate as which can be calculated as E volume of all in aggregate into volume of fine aggregate into specific gravity of my fine aggregate into 1000. Okay, so 0.723 same into 0.41 into 2.517 into 1000. So this is the final 746.11 kg per meter cube. So all these ingredients, okay, including the super plasticizer or the admixture, so which can be calculated precisely. So finally we can make the list. Okay, so this is cement is 350 kg per meter cube, water is 154 liter per meter cube, fine aggregate required is 746.11 kg per meter cube, coarse aggregate 20 mm is 715.36. So we can select the total coarse aggregate 1192.26. We are using 60% of this 20 mm aggregate which will be used. So 60% of that we are calculating 715.36 kg per meter cube. Similarly, coarse aggregate of 10 mm and downside is nothing but what? Total aggregate weight. So 1192.26. In that 40% we are using particularly of 10 mm size. So the value found is 476.90 kg per meter cube. Chemical admixture mass is 1.75 kg per meter cube, and the water cement ratio which we have taken is 0.44. So this is about the mix design procedure by using the updated code, updated IS code, which is IS 10262 2019. Okay, so that's all for today. Thank you.